Welcome back to Jackson Square. Today we're looking at translating from verbal to numerical. So that's very important and significant for anything when we're talking about expressions or equations. So I'm going to reference this to TEK 6.7b, which says I can distinguish between expressions and equations verbally, numerically, and algebraically. So we're going to be taking words and make them into numerical expressions or equations. So the first part of that is knowing some keywords when we are reading our verbal expressions. There's some words that we know, vocabulary words that pertain to certain operations like addition, subtraction, multiplication, division, and even equals. So when we think of addition, some of the common words that we'll see is the sum or a sum of. We'll see more than, and we might see total. For subtraction, we'll see words like difference and possibly less than. When we think about multiplication, definitely times, right? And product. Division, we want to see things like divided by, or we may see things such as quotient. For equal, is the biggest one you will see. This is that, okay? We might see the same as, or we might even see is equal to. There are many more that you may see when you're translating. These are just a little bit of a starter. And in your notebook, we will have a full list of things that could possibly be words you'll see when you're translating. So let's jump right in and do a few examples. So here on the side, I have a few examples, some things that you will commonly see. And I just want to show you how I translate when I see these. So the first thing I do is I read it once, then I go back and I write above the words what each one of those words means, and then I take that and put it all together. So let me grab a pencil and let's get started. The first one says the difference between a number and 5. So I see difference, and I see a number, and I see 5. Well, the first thing we want to know is anytime you see a number is our variable. It's a letter that stands in the place of a number we don't know yet. So for a number, let's say this time I'm going to use x, okay? Difference means I'm subtracting, and then 5. So I would translate this to mean x minus 5. The difference between a number and 5. So I'm going to subtract 5 from x. That's what that means. The next one says 19 added to a number. 19 added and a number. So first I know 19 is the number 19. My operation word is added, that's addition, and a number. This time I'll use y. Okay, so that one was pretty easy and straightforward. 19 added to a number y. Since it says added to a number, I'm going to put y in front, y plus 19. But could I put 19 in front? Yes, because hopefully you know that addition and multiplication are commutative. The numbers can travel and be in different places, and I would still get my same answer. So if you write 19 plus y or y plus 19, it does not matter. However, make sure you note that in subtraction and division, order is important, okay? Next, we have k less than 7. K less than 7. Okay, that's our variable. So they didn't give us a number this time. They gave us a specific letter, less than, and then 7. So we know K and we know 7. Those are already given to us. Less than, we know, means subtraction. But there's something very important that I want to point out here. Anytime you see a problem and it says that something is less than or more than, that variable, letter, or number in front of the word less than goes to the back. Okay, so what do I mean goes to the back? That means when I write my translation, I'm going to put K behind the other thing. So K is less than 7. That means 7 minus K. Remember, in subtraction and division, the order does matter. So 7 is less than K. 7 minus K is what that means. Anytime it says less than or more than, that number, variable in the front, the words in front, that thing is going to go to the back, okay? So let's remember it's going to go to the back. Let's look at another one that's similar. It says 8 more than a number. 8 more than a number. So we have 8, we have more than, and then we have a number. So this time they didn't give us a variable, so we can make our variable, hey, let's make it a J for Miss Jackson, okay? My dot won't go. More than, hopefully you know that more than is addition, and our number we're doing is 8. So remember, anytime it has less than or more than, this number is going to go to the back. It's going to go to it's going to be the second term. It won't be the first. So 8 more than a number. So that means J plus 8. Okay? J plus 8. Anytime more than or less than, it goes to the back. But again, it's commutative because it's addition. So J plus 8 or 8 plus J, I would still get the same answer. But if you're looking on a test and multiple choice, most likely when you see more than or less than, it's going to be behind, okay? So those were just a few quick examples to translate. So let's jump into a few more. So here on this page, you will have your extensive list of terms for addition, sum of, more than, added to, altogether, plus, increased by, combined, total, subtraction, difference, minus, giveaway. If somebody gives something away, that's a subtraction, right? How many more? How many more does Jade have than Tiffany have? That's a subtraction. Less, if they lost something, less than. Multiplication, each, groups of, twice, double, triple, product of, multiplied by, area. Remember, area is length times width or base times height. That's always multiplication. Times. We have per. So per goes in each category. It's a little bit tricky with per, so you have to make sure you know and understand the situation. If I'm buying bananas and it's 39 cents per pound, that means for each pound I buy, I'm paying 39 cents. So that's multiplication. Okay. So division, we have words like split up, share, quotient, equal parts, distribute, evenly, divided by. And again, there's that per. Sometimes you may want to know how much she traveled if she can get 25 miles per gallon, and that per gallon is each gallon. But if I traveled 10,000 miles, you want to know how many hours I traveled if I could drive 25 per gallon. So again, per is a little iffy. I normally put it in the multiplication category. Some may put it in division. It depends on the problem, okay? Equal is, equal to, will be, the same as, was, were, equals, equivalent to. Most common one that you guys will see is Is means an equal sign, especially when we're translating and we're trying to tell the difference between an equation and an expression. Remember, expressions do not have equal sign and equations do. So if you see the word is, you automatically know it is definitely an equation, okay? So let's look at verbal to algebraic, some little definitions. Multiplication, how does multiplication look? Multiplication will be placed side by side with the coefficient in front of the variable. Remember, coefficient is a number. Variable is going to be a letter that takes the place of a number we don't know. So the product of 9 and n, you would have 9 in front and n in the back. Now, can you write n in front and 9 in the back? You could write n 9. You could. It's commutative, baby. It's commutative. Where's my car? It's over here. It's Commutative. Okay, so you could write the N in the front and the 9 in the back. However, the way that you will see it always written is with the number in the front and the variable, okay? You're going to always see it that way. That's just like standard worldwide mathematician way of doing it. So you wouldn't be wrong if you put the N in front, but it would just be weird, okay? Q times 12, okay? So it says Q times 12, but again, we know that we need to have the 12 in the front and the Q in the back. So I'll let you do the rest of those. With division, you must determine which term is the numerator and which is the denominator. That's very important. Which is the numerator and which is the denominator. Most often when you're looking at that, whatever comes first is the numerator and then the next one is the denominator. Not too hard. So it says the quotient of x and 6. The quotient of x and 6. So x is going to be my numerator and 6 will be my denominator. And although this is written with a obulus, most times in algebra, you're going to see a fraction bar. So make sure you're getting your mind set that we're moving into algebra. We're already there, right? We're moving more algebraically. So you would probably see x fraction bar 6 in fractional form. Very few times will you see that obulus, okay? The quotient of 4 and q, that one's similar to this one. This one is straightforward. 9 divided by c. Like, that's not a secret, right? 9 is being divided by c. That means 9 is my numerator and c is my denominator. So I'll let you guys, again, go ahead and finish the other two. Shouldn't be hard to match those up. Here on this last page, you are going to match all of these up, write an expression or equation based on the information below. So here I want you to pause and practice and come back and check. Welcome back. So I hope that wasn't too hard or too difficult. I hope you used your table and you were looking for those key operation words as well as the is and the equals to or same as or equivalent, and you were able to successfully come out good. Great. So let's go over a few. So the first one says 4 times W is 18. So I know that's an equal equation. So 4 times W equals 18. Then we had N divided by 7. Remember, fractional form. N is our numerator, 7 is our denominator. The next one, 14 is half of G. 14 equals 1/2 G. So 14 is, that's an equal sign, half of G. That's half times G. Or you could have made G the numerator and 2 the denominator. And we'll look into this in chapter 6. But if you wrote it this way, that's fine as well. Here we have the quotient of m and 5 plus 9. Remember, m is that numerator, 5 is the denominator, and you're adding 9 to it. 1/3 the sum of 11 and p. So we're taking 1/3 of the sum of 11 and p. That means 11 and p are being added together, and then we have to remember grouping. We put them in parentheses, and we're going to take 1/3 of that. This could also look differently. 11 plus p could be our numerator, and we can have a fraction bar, and 3 could be our denominator. There are many ways that you could see these things. So I want you to keep your mind open, like I said, to fractional form, fraction bars, getting away from like the obulus, the brackets, the x for multiplication. Now x is going to be a center dot, or it's going to be that coefficient next to the variable. So I hope that this helps. Let's go practice.